Hello, good morning. How are you all doing today? Happy Tuesday. It's course day, which of course, because we already created a course, we're on LMS day, which is updating LMS, making it ready for the course, upgrading the course, doing all those fun things. Zilby's here, although he doesn't want to be on the table, so I don't have a cat cam for him. But you might hear him meowing as he wants my attention for all sorts of other things. But we'll go and deal with that later. So in the meantime, I've got everything set up locally. So here's my here's the local core. Yeah, here's our local LMS setup. We have Sura set up locally too. Of course, that jot that we used is expired now, but that's fine. We were pretending to be a learner, which is, I believe, our test learner. And looking at this, we have to choose what we're going to work on next. Hey, Zilby, you're going to hang out with us. Cool. Now, I had said that I was going to go and potentially organize a bunch of these, and I kind of didn't. So you okay, Zilby? We'll just choose something here. Something's bothering Zilby. He might. I don't know what he needs. If he needs something, I'll take him up and take care of him. Yeah, that was a little bit weird. It can feel it coming in the air tonight. Something's happening. You know what? I am gonna go take a look and make sure that everything's okay. But also, hello, Banzi. How are you doing today? So I will be right back, and then we'll start for real. All right, I'm back. Zilby's fine. He wanted to, go poop though, and he doesn't like to go on his own. He wants somebody to be there to hang out with him, protect him, I guess. So anyways, that was that. All right, now continuing on with where we left off. Add a lesson for using Docker without sudo on Linux. Yeah, boot partner. I've heard that dogs and cats tend to do that a lot. Because that's when they're very vulnerable, and they like out in the wild they might have like another cat keep a watch out for them. But of course, Zilby's an only cat, so he wants us to watch out for him. He sometimes hangs out with us, but he generally doesn't care about us being attacked while we're in the restroom. So I don't know what that says about us. He did not follow me back downstairs again, though. He wanted to hang out upstairs and look out the windows, so maybe he'll join us later. Okay, so this was some feedback that we got, which is that we want to add a lesson for using Docker without sudo, because specifically on Linux, because if you install this on Mac or Windows, the installer will make it so that you don't have to you just can use Docker and everything's fine. But on Linux, if you go the normal install route and you just install the engine, you do need to use sudo to run it. Now, you're right, sudo is problematic because Docker is running as root, no matter what you do. So there's nothing that we can do to make Docker run as not root because it needs access to kernel stuff. It needs very low access to basically a lot of things. So making Docker run without root privileges is not the way to do this. It's more of, we could add ourselves in to a group that allows us to run Docker as root. So, but it does seem to be like a big request of like, okay, can I do this? So the question would be, how do I want to write this to like basically say like, here's how to do that, but also here's like why you might not want to do this, or at least if you're going to do this, please be aware of the ramifications of this. You're a big fan of red team breakdowns. Yeah, there are a lot of potential problems. Well, there's interesting security ramifications that don't exist on Mac and Windows because there's an extra VM that's in between the rest of your computer's resources and Docker, which is all behind the scenes. That being said, I believe that this would be like a, hey, can I do this? Can I do this? Can I do this? Can I do this? Like over and over and over again. So this does make sense to write an article for it. So that being said, I'm wondering if I want to create, a an article repo for this, just for Docker course, which might make sense. So I think maybe I'll create one there instead of just all of the course repos like sort of together. So let's rename this Docker course. Double as a Medium post. We can write it as a Medium post, and then also this could be a preview post because we want everybody to be able to see it and read it. I mean, I could potentially do something like that. Also, we can create a we can do all the YouTube, like a YouTube video, YouTube short, all the things. I haven't really looked to see what other people have been saying on a topic. Is there much out there for it? There's always superficial stuff. I don't know if I can go really beyond the superficial stuff though, because I don't have the knowledge to properly deep dive without potentially going into like information that I'm like only half knowledgeable of. I didn't really use Docker as a systems administrator, so I never got into it until I was a developer. So if I was at that point in time, I would have had access to my security team and probably would have gotten a lot of good information from them. Mostly 1-minute reads, that's pretty short. That sounds very superficial. All right, let's touch, what is this going to be called? I guess I'll do the, well, if I'm going to move that otherwise, we already have a README in the other directory. Let's, we'll call this running Docker without sudo. On Linux. You remember searching for it in like 2021 to 2022 during the crypto gold rush. Yeah, that's a good point. Now, there's if I remember correctly, good information on docker.com. They have in their documentation somewhere. I want to say, oh, hardened. No, that's Docker desktop. Okay, so I think this is it. We should read this entire article, and then, I mean, I kind of want to just say, hey, if you're running Linux, you need to read this. But we should read it just to make sure that it's exactly what we think that it is. And then go from there. All right, let's do some reading. Docker security. There are 4 major areas to consider when reviewing Docker security: the intrinsic security of the kernel and its support for namespaces and C groups, the attack surface of the Docker daemon itself, loopholes in a container configuration profile, either by default or when customized by users, the hardening security features of the kernel and how they interact with containers. Kernel namespaces. Docker containers are very similar to LXC containers, and they have similar security features. When you start a container with Docker run, behind the scenes, Docker creates a set of namespaces and control groups for the container. Namespaces provide the first and most straightforward form of isolation. Processes running within a container cannot see, and even less affect processes running in another container or in the host system. Each container also gets its own network stack, meaning that a container doesn't get privileged access to the sockets or interfaces of another container. Of course, if the host system is set up accordingly, containers can interact with each other through their respective network interfaces, just like they can interact with external hosts. When you specify public ports for your containers or use links, then IP traffic is allowed between containers. They can ping each other, send, receive UDP packets, and establish TCP connections, but that can be restricted if necessary. From a network architecture point of view, all containers on a given Docker host are sitting on bridge interfaces. This means that they are just like physical machines connected through a common Ethernet switch, no more, no less. How mature is the code providing kernel namespace and private networking? Kernel namespaces were introduced between kernel version 2.6.15 and 2.6.26. This means that since July 2008, namespace code has been exercised and scrutinized on a large number of production systems. And there is more. The design and inspiration for the namespace's code are even older. Namespaces are actually an effort to re-implement the features of OpenVZ in such a way that they could be merged with the mainstream kernel. And OpenVZ was initially released in 2005, so both the design and the implementation are pretty mature. Okay, so basically, it is saying that stuff that runs inside the container, even if it breaks out, shouldn't have access. Now, there's a popular idea in security, which is there is no such thing as like actually like truly isolation and security. Like even with the best virtual machine, you're gonna have like there is gonna be some way for something to break out, and they just because they don't know about it doesn't mean that vulnerability doesn't exist. Now, security wise, what we can do is the best effort, right? Like if they give us configuration options to like fend that off, that's what we can do. Control groups. Control groups are another key component of Linux containers. They implement resource accounting and limiting. They provide many useful metrics, but they also help ensure that each container gets its fair share of memory, CPU, disk I/O, and more importantly, that a single container cannot bring the system down by exhausting one of those resources. So while they do not play a role in preventing one container from accessing or affecting the data and processes of another container, they are essential to fend off some denial of service attacks. They are particularly important on multi-tenant platforms like public and private PaaS, platform as a service, to guarantee a consistent uptime and performance, even when some applications start to misbehave. Control groups have been around for a while as well. The code was started in 2006 and initially merged in kernel 2.6.24. So this is all kernel level stuff we're talking about here. Things that if you have installed I guess like one of the popular systems, I would guess that you get all this stuff. But if you've installed like, I don't know, the OS that comes to mind is like something like Gentoo, or you've done some kernel hacking to sort of like change what features are available in the kernel, it's possible that you may have turned off one of these features or have somehow like, I don't know, done something to like add a vulnerability in. Gentoo doesn't seem to be quite as popular anymore. Like I used to hear a lot of people using it. Now I hear people using, not Alpine as their main driver, Arch. Most people use Arch now, which I can't remember. Does Arch like make it really easy, like during install time, to just like turn off a bunch of kernel features? Or force you to recompile the kernel yourself? Docker daemon attack surface. Running containers and applications with Docker implies running the Docker daemon. This daemon requires root privileges unless you opt into rootless mode. Interesting. I didn't realize that there was a rootless mode. And you should therefore be aware of some important details. First of all, only trusted users should be allowed to control your Docker daemon. This is a direct consequence of some powerful Docker features. Specifically, Docker allows you to share a directory between the Docker host and a guest container. It allows you to do so without limiting the access rights of the container. This means that you can start a container where the host directory is the / directory on your host, and the container can alter your host file system without any restriction. This is similar to how virtualization systems allow file system resource sharing. Nothing prevents you from sharing your root file system, or even your root block device, with a virtual machine. This is a strong security implication. For example, if you instrument Docker from a web server to provision containers through an API, you should be even more careful than usual with parameter checking to make sure that a malicious user cannot pass crafted parameters, causing Docker to create arbitrary containers. So the concern here is that we might run, I think this is where we should like keep some notes here. So let's do concerns. A malicious, like we can accidentally run a malicious script or program that will attempt to use Docker as our user, because any program that we run as us runs as us. They can't switch to root because that has a password on it. You can't switch to root if it doesn't have a password, if I remember correctly. Also, if you run root without a password, you have bigger problems. At least if it's a system that you can log into. Let's see. Now, because you can do pretty much anything like write, it's not that we can run it and say like, hey, we're running this and we've passed like / into Docker. It's more of the script can, pretending to be us, run root and pass / in. And that could be pretty bad. For this reason, the REST API endpoint used by the Docker CLI to communicate with a Docker daemon changed in Docker 0.5.2 and now uses a Unix socket instead of a TCP socket bound on 127.0.0.1. The latter being prone to cross-site request forgery attacks if you happen to run Docker directly on your local machine, outside of a VM. You can then use traditional Unix permission checks to limit access to the control socket. You can also expose the REST API over HTTP if you explicitly decide to do so. However, if you do that, be aware of the above-mentioned security implications. Note that even if you have a firewall to limit accesses to the REST API endpoint from other hosts in the network, the endpoint can still be accessible from containers, and it can easily result in a privilege escalation. Therefore, it's mandatory to secure API endpoints with HTTPS and certificates. It is also recommended to ensure that it is reachable only from a trusted network or VPN. Basically, don't set up the Docker REST API. Like, just don't do it at all. They stopped doing it. But apparently we can, apparently you can set that up yourself. And you can like configure it to now serve that. And this is a terrible, terrible, terrible idea. However, that is not on by default, and therefore not something we have to worry about here. You is my project? No, so you is not my project. I'm using you, and I built this thing in you. So this is the project that we built in you. It's an LMS. And it allows people to log in, create accounts, and then take courses. How to use HTML table tag in you? Do I use the HTML table tag in you? That's a good question. Can I search in here for table? I guess I'll search for that. I mean, a pull request for it? Oh, it wouldn't be in here. It wouldn't be in here. Okay, hold on. I have another repo that it would be in. What did I call it? It's my U component library, YCL. There we go. Okay, so here's how we can create a table tag in U, is just use the table tag like this. So if we jump into here, I have my HTML macro, and then just table, I add a class to it in this case, and then just normal table, right? Like exactly what you get from MDN if you're looking for the documentation for it. The only difference is, well, I guess it's not really even a difference, just normal U stuff to like then inject things in. So like here I'm getting under the row, and then I have a bunch of THs for each title, and then I do the same thing under T body to get that. So you can use a table exactly like the way you would use a in U, you can use a table exactly like you would use it in React or Vue or just native HTML. Does that answer your question, Waleed? Let's go back to this. Awesome, great. You can also use Docker host, SSH, user host, or that instead if you prefer to SSH over TLS. But again, I don't think that it's a good idea to like be able to run commands remotely like this. So I wouldn't recommend it. The daemon is also potentially vulnerable to other inputs, such as image loading from either disk with Docker load or from the network with Docker pull. As of Docker 1.3.2, images are now extracted in a chrooted subprocess on Linux Unix platforms, being the first step in a wider effort towards privilege separation. As of Docker 1.10.0, all images are stored and accessed by the cryptographic checksums of their contents, limiting the possibility of an attacker causing a collision with an existing image. This is good. More good things to increase security. Excellent. Finally, if you run Docker on a server, it is recommended to run exclusively Docker on the server and move all other services within containers controlled by Docker. Of course, it is fine to keep your favorite admin tools, probably at least an SSH server, as well as existing monitoring and supervision processes such as NRPE and collectd. Basically, isolation. We want, if you're going to run Docker on a VPS, only run Docker on the VPS. If you want install an app or whatever, that should go inside of Docker, or create a new VPS for it. Can you start a project that makes operating system in Rust? I will probably not do that because that would be a huge project, and I don't know. I don't have the it's not like something I'm really super interested in. Although there are people who have been making an operating system in Rust. So that is something that is being done. Linux kernel capabilities. By default, Docker starts containers with a restricted set of capabilities. What does that mean? Capabilities turn the binary root-non-root dichotomy into a fine-grained access control system. Processes, like web servers, that just need to bind on a port below 1024 do not need to run as root. They can just be granted the netbind service capability instead. And there are many other capabilities. For almost all the specific areas where root privileges are usually needed, this means a lot for container security. Okay, so interesting. So if we don't need to bind to a port below 1024, you could run Docker without root? Is that what it's saying? And that's also, oh, no, that's containers. Containers don't run as root. Is that true? That's interesting. Same thing for a database engine. I don't really have any interest in necessarily creating a database myself, but there are plenty of people who have been making databases in Rust. Typical servers run several processes as root, including the SSH daemon, cron daemon, logging daemons, kernel modules, network configuration tools, and more. A container is different because almost all of those tasks are handled by the infrastructure around the container. SSH access are typically managed by a single server running on the Docker host. Cron, when necessary, should run as a user process, dedicated and tailored for the app that needs its scheduling service, rather than as a platform-wide facility. Log management is also typically handed to Docker or to third-party services like Loggly or Splunk. Hardware management is irrelevant, meaning that you never need to run udevd or equivalent daemons within containers. Network management happens outside of the containers, enforcing separation of concerns as much as possible, meaning that a container should never need to perform iconfig, route, or IP commands, except when a container is specifically engineered to behave like a router or firewall, of course. So this is basically saying the containers by default are not going to run as root. The containers, not Docker itself. Docker itself runs as root, but then it runs each container not as root in order to not give it access to all these different things. And if you need to give it access to all these different things, there are ways to do that, but also not recommended unless you really know what you're doing. This means that in most cases, containers do not need real root privileges at all, and therefore containers can run with a reduced capability set, meaning that root within a container has much less privileges than a real root. For instance, it is possible to So this is interesting because I was always under the impression that root within a container was root. And if you broke out of the container, you were now root. But what this is saying is that's not true. If you break out of the container from root, you are you're only able to do this. Is this it? Let's see. Deny all mount operations. Deny access to raw sockets. Oh, no. This is what is denied to the user root coming, like if it breaks out. It's denied mount operation, so it can't mount something from like a remote disk drive to like then install malware. Deny access to raw sockets. Deny access to some file system operations, like creating new device nodes, changing owners of files, or altering attributes. That's a big thing to allow like root access. Deny module loading. So this is really big. Yeah, I want to be here. Come back to here. So this is less of a concern and more of like a good thing, which is root in a Docker container. This means that even if an intruder manages to escalate to root within a container, it is much harder to do serious damage or to escalate to the host. This doesn't affect regular web apps, but reduces the vectors of attack by malicious users considerably. By default, Docker drops all capabilities except those needed. And there's a list of what those needed are. An allow list instead of a deny list approach. You can see a full list of available capabilities in Linux man pages. One primary risk with running Docker containers is that the default set of capabilities and mounts given to a container may provide incomplete isolation, either independently or when used in combination with kernel vulnerabilities. Docker supports the addition and removal of capabilities, allowing use of a non-default profile. This may make Docker more secure through capability removal or less secure through the addition of capabilities. The best practice for users would be to remove all capabilities except those explicitly required for their processes. Now, if we take a look at these, this first one is, these are the capabilities that are needed. This is it's an allow list as opposed to a deny list. So cap chown, so chown, okay, chown. I don't know what DAC override is. Set a file system set ID, file system owner, make node, set raw. Okay. Set a bunch of these things. Okay, so net bind service, syschroot, kill process, audit write. Okay, that's not too bad at all. That's not a very. These are I've never done Linux. I've never done kernel Linux dev, and so therefore I don't know what these are. Hugh, hello. How are you doing today? A DAC override denial means that the offending process is attempting to access a file with the incorrect Unix user group world permissions. The proper solution is almost never to grant the DAC override permission. Instead, change the Unix permissions on the file or process. So it has the ability to change that. Interesting. That's not great. So I can definitely see that we might want to like remove that. If I remembered yesterday, we discussed about the question mark instead of unwrap, but today when I try to changes, unwrap statement, face an error, tell me, can I use the question mark when assigning function value to a variable? You can use the question mark, and it requires if you return a result or an option, you can use the question mark. But the function that you're using the question mark in must also return the same type of thing that got returned that you're using a question mark on. So that would be an option, or the exact same type of result, because there are different results, right? Like I was using the anyhow result, and that allows me to use the question mark on many different things. But if you're using something like an standard IO result, then that you can't use that with like a standard FS result. Those are different things. The error should tell you exactly what the problem is. And then, okay, here's the actual list of what these capabilities are and what they mean. So we can take a look at this now here and compare it in here. Bypass file read, write, and execute permission checks. Yeah, so discretionary access control. So basically, oh yeah, I don't have ownership of that, but I can run it anyways, which is not great. That's not great. Now we could remove that from Docker. We could potentially remove everything and then just put them back in until whatever we're trying to run works. Docker content trust signature verification. Docker engine can be configured. Okay, so this might be something good to go into, which is Linux kernel capabilities. So root, but containers have a whitelist. I guess it's now an allow list. Containers have an allow list that determines what kernel permissions they have. And we might want to go in and figure out which ones we want we would want to remove. Docker content trust signature verification. Docker engine can be configured to only run signed images. The Docker content trust signature verification feature is built directly into the Docker-D binary. This is configured in the Docker-D configuration file. To enable this feature, trust pinning can be configured in daemon.json, whereby only repositories signed with this user-specified root key can be pulled and run. This feature provides more insight to administrators than previously available with the CLI for enforcing and performing image signature verification. I believe that this is mostly for custom repositories. Like if we had our own repository, you might want to set something up like this. Other kernel security features. Capabilities are just one of the many security features provided by modern Linux kernels. It is also possible to leverage existing well-known systems like Tomoyo, AppArmor, SELinux, GRSec, etc. with Docker. While Docker currently only enables capabilities, it doesn't interfere with the other systems. This means that there are many different ways to harden a Docker host. Here are a few examples. You can run a kernel with GRSec and PAX. This adds many safety checks, both at compile time and runtime. It also defeats many exploits, thanks to techniques like address randomization. It doesn't require Docker-specific configuration since those security features apply system-wide, independent of containers. If your distribution comes with security model templates for Docker containers, you can use them out of the box. For instance, we ship a template that works with AppArmor, and Red Hat comes with SELinux policies for Docker. These templates provide an extra safety net, even though it overlaps greatly with capabilities. You can define your own policies using your favorite access control mechanism. So this is out of scope for the course, but if you know this, it might be good to know that you can do something like this. Systems administrators, like modern ones who are using this, should absolutely know this and just like use this. But I was before this time, so I never used it. Let's see. You know any channel or source where you can learn how to code B-tree or other database algorithms? Wasn't John Hu programming a database? Like, he's talked about database type stuff a lot. So maybe like he might be a better streamer to chat with. He doesn't stream every day, but when he does stream, it's pretty popular. He's a lot of people stop by, and he might have more information for you or something like that, or his community might too. Just as you can use third-party tools to augment Docker containers, including special network topologies or shared file systems, tools exist to harden Docker containers without the need to modify Docker itself. As of Docker 1.10, user namespaces are supported directly by the Docker daemon. This feature allows for the root user in a container to be mapped to a non-UID0 user outside the container, which can help to mitigate the risk of container breakout. This feels big. This feels really, really, really big. This facility is available, but not enabled by default. Okay. So here's what this is trying to tell us. Right now, the root user in Docker is root, but with minus some capabilities. But as we've seen, those capabilities include some, they can still do quite a bit of damage to your system. However, it looks like we can state that the root user inside a Docker container could actually be just a normal user. So we can create a user that has no permissions on the main system and then move it in there. We should, I think today's stream is going to be less about working on Docker. I kind of now want to, I'm going to change the stream titles because now we're just playing with Docker. Hold on. Change the stream titles. We are now, exploring Docker security live. Okay, that's on YouTube. And that is on Twitch. All right, this is what we're going to be working on today. So this feels really, 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 really important. So we can set the root user in a container to map to a non-root user on the host system. Refer to the daemon command in the command line reference for more information on this feature. Additional information on the implementation of user namespaces in Docker can be found in this blog post. Okay. So we're going to want to go in there and a blog post to help us deal with it. Conclusions. Docker containers are, by default, quite secure, especially if you run your processes as non-privileged users inside the container. You can add an extra layer of safety by enabling AppArmor SELinux GRSE or another appropriate hardening system. If you think of ways to make Docker more secure, we welcome feature requests, pull requests, or comments on the Docker community platforms. So, and then a bunch of related information, which I don't know if we need right now, but definitely good to know. Okay, so a bunch of things to look into now. I think we started from the right. Okay, So run the Docker daemon as a non-root user. Is this something we want to, well, we should probably look into it. Now, this is all for Linux type stuff, which is going to be a little bit difficult for me because I'm on a Mac and I can't run this as Linux. So we have a couple choices here. I can't, first of all, that's not what I want to do. That's what I wanted to do. I don't have a standalone VM installed. I basically just have the VM for that, like Docker installs behind the scenes, but that's not going to count. We want our own thing. So how do I want to do this? I could log into AWS and spin up a VPS, and then we can do stuff in there. I cannot do this in GitHub code platforms, code something. I forget what it's called. Where they give you a VM, because that has Docker in it already, and I don't think I can turn that off. I don't think I can turn off the feature for Docker. My Linux system is still broken. But I do have a Raspberry Pi 4. Let's see what I have. Let's see, USB-C stuff. I don't know if I'll be able to share the screen on this. I think I did at one point in time, a long time ago on stream, when we were making some game things in Rust, but that's been years. Let's see, I have something installed on it. Because I see the card. So yeah, I mean, I have a nice little Raspberry Pi 4. So we could do something in this. If I, oh, this case wants a power charger. Do I even have that? Or did I lose it? Okay, so I have a power brick for USB-C, and that could boot this thing. Hold on, let me try booting this, because we could do some playing around with this without a network, just completely isolated from everything, and run it like Docker can run on a Raspberry Pi 4. They're really powerful. So let me go plug this in. Oh, and an ad is starting in 3 minutes, so heads up for that too. Okay, so where did that cable go? Here you are. I assume that this is going to be power for you. A light turned on. That's a good sign. Um, but now, what am I going to use to like actually get this onto a screen so I can see what? Let's see. I have micro HDMI to HDMI. So I remember I bought this cable a long time ago. I probably have another one in here too that I've already opened. I should organize all my junk cables. I've seen some of the other creators do that too, and it's really nice when that works. And of course, they all tangle them up with each other. That's great. Okay, is this it? Yes. Okay, so I've got a micro HDMI to HDMI. So let's plug you in. I was always so shocked that the Raspberry Pi 4 started supporting the ability to connect 2 monitors to it, which just feels overkill for a Raspberry Pi, but also awesome at the same time. They're really leaning into the just use it as your own computer. With how cheap they are, you could just actually run it. If you don't need like to game or at all, just run this as your computer. All right, I need to go find the other side of the screen to actually plug that in. There you are. Okay, so luckily I got chat on my main screen here, so I can actually move this monitor over. And we'll take a... Yeah, there we go. Okay, so I've got that up and running, which is great. I need a mouse. I have one of those little dongle things for this mouse, but because I always use the USB the Bluetooth for it, I just may have misplaced it. Okay, well, I bet. Okay, an ad break started. Anyways, I'm gonna go upstairs and go find a wired mouse that I can use for this. So, quick break. All right, I am back. We have two options for mouse. So I actually found a wired mouse. I also found a dongle, which may or may not be to this mouse or another wireless mouse. Let me try that. It's amazing that these also come with 4 USB, which is awesome. Okay, so you're up and running, and then if I change you to that, no. Okay, see, that's not the USB, that's not the Bluetooth dongle for this wireless mouse. That's for a different wireless mouse. Cool. This will work though. What? Or not? Oh, did it crash for some reason? Or is that USB port dead? The mouse didn't. Let me try rebooting it. Maybe the dongle did work. Oh, something happened. Failed to open the SD card. I mean, that's definitely not good. Okay. Trying the good old unplug and replug it in trick to see if that works. Failed to open device SD card. Okay, that's still not good. Wait. Okay, failed to open it again. Okay, let me try it. Did I like put it in backwards? It had loaded to a desktop initially. No, okay. Yeah, it has to be that way. That's the only way it fits. The only different thing that I had was the USB mouse in, which I can't imagine that that is causing the problem. Yeah, failed to open that. Okay. So you were fine and then you broke. Cool.